Hey everyone, I wanted to take some time to go over the Studying Population Dynamics Part 1. There were some questions that were commonly missed, but I thought I would take some time, since there's only 4, to go over each one in a little bit more detail and hopefully help you guys clear up some misconceptions if you were having trouble. So scenario 1, I believe we went over this in most of our classes as we got started. It tells you that when scientists are studying deep ocean vents, they look at a small area. That is the first clue that you have as to what method of population study is being used, that we're starting in a small area. And they were amazed to find that a number of deep ocean crabs, this one picture of crabs, and they show as a deep sea ocean vent in this small area. So this box represents about 4 square feet of ocean floor, and there are approximately 8,250 square feet of ocean floor surrounding one vent. So right there I see that they're giving me a small area, but comparing it to the whole entire area or a larger area. So right away, when I know that I'm looking at a small area and I'm going to be using that to speak for a larger area or to signify the larger area, I know that method's going to be sampling. And to find my answer, I need to first figure out how many crabs per square feet or per square foot there is, and then I can multiply that over my entire area. So to do this, I would look at the image and I would say I see 1, 2, 3, 4, 5 crabs, and I know that there are 5 crabs per 4 square feet. So I would do 5 crabs divided by 4 feet squared, and that would give me 1.25 crabs per square foot. Okay. And so now I'm going to take this 1.25 crabs per square foot and I'm going to multiply that by the total square footage. And that would be 8,250 square feet. Now my feet squared is going to cancel out because I have crabs over feet squared here and then feet squared here, so it would be feet over feet cancel out, and I'm left with a number of crabs. So that number of crabs is going to be equal to 10,312.5 crabs. And since I'm not so keen on counting half a crab, I'm going to round up to 10,313 crabs. And again, this is sampling because we look at a small area and multiply it over the larger area. Okay, here we have a theory on daylilies, which produce 1 open flower, right, per individual plant. So there are some flowers here that aren't quite open, so those could belong to the same plant, but only 1 blooming flower per plant. So the first thing I'm going to do is say we're trying to find out how many plants there are in the daylily population pictured above. So we're just talking about this population in the picture. So that's a relatively small population. I can probably count every one of them. So I would say 1, 2, 3, 4, 5, 6, 7. Looks like there are 7 open flowers to me. And that would be my population. So my answer would be 7 flowers. And when I count every single one of the organisms in a population, I count them directly. We know that is direct observation. Okay, 2 more. This question is about prairie warblers and how they are banded and given a radio transmitter to study their habitat location, reproductive data, and longevity statistics. So right there, I know that I'm gathering a lot of information about the organism, and I know that they're being outfitted with a transmitter. So the only option where we actually have a transmitter or we mark the organism would be mark and recapture. So I know that that's my method. Then I have to figure out the number or the estimate of prairie warblers in the population. So to do that, I'm going to use the equation here. This should be divided by. So it's going to be the number that were tagged. So there were 113 that were originally tagged. Multiply that by the number that were caught, and so the next time around when they did the recapture there were 92 that were caught, and then we're going to divide that by the total number caught that had tags. So the second time around when they recaptured them, 75 had tags, and that should give you 138.6, and we would just round that up to 139. We don't need to count fractions of birds. All right, so 139, and then what might have happened to the tagged prairie warblers that did not return to the habitat? 2 hypotheses below. Hope you guys were able to come up with some creative answers here. It could be loss from predation. So that would be predators. Maybe it would be loss from disease, or maybe the birds decided to immigrate to a new location, a new population. So there's really a lot of options as to what could cause a population to go down, because there are endless possibilities for death, and then there's also immigration. So those are really the 2 main ways that a population can decrease. Okay, blue heron. So the picture didn't copy over here, but if you remember from the picture, there were 11 nests in the trees. And we said that we want to know the number of blue herons after the breeding season. So after the breeding season, there would be 3 chicks approximately and 2 parents per nest. So that means that there would be a total of 5 birds per nest. So if I multiply those 11 nests by 5, that'll give me 55 birds. So some people might have just multiplied by 3 or multiplied by 2, or maybe you counted 10 nests. I didn't take points off there. What you should know is that there were 11 nests, and that gives you 55 birds, because 5 birds per nest. And then we were measuring the nests. We were counting the nests. We weren't counting the birds. So we used our information that we knew about the birds, and we counted the nests, so that would be indirect observation. All right, I hope this video helped clear up some misconceptions with the different methods of population study. Please reach out to your instructor if you have any more questions.